So I think since we have a group here that's drawn from a number of different areas, it may be useful to kind of go around and just say who you are and where you're from and maybe a little bit about your background. So start here with Ron, since he looks eager.
Yeah. I'm Ron Stauffer. I'm from GFDL in Princeton. What do I do here? I guess climate modeling.
Yeah.
I'm Phil Rash. I'm from NCAR. I'm a climate modeler also. I'm a chair of IGAC, which is an IGBP organization for studying atmospheric chemistry.
I'm Guy Brasseur. I'm from NCAR. I'm an atmospheric chemist, modeler. I used to be the chair of IGBP, which is related to what you just said.
Yeah.
Okay. I'm Claire Granier, and I'm from both NOAA and CNRS in France, and I'm working mostly on emissions and chemistry transport modeling.
I'm Dave Lawrence, and I'm from NCAR as well, and I'm here basically representing the land model and the biogeochemistry, lesser extent biogeochemistry working groups from the CCSM.
I'm Norman McFarlane. I'm the director of the SPARC project office at the University of Toronto. I do that about half the time. The other half of my time I spend at the Canadian Centre for Climate Modeling and Analysis in Victoria, where I still do a little bit of work.
I'm Olivier Boucher from the Hadley Centre, out of the Met Office, with a background in atmospheric aerosols, and I'm interested in nerve system.
I'm Peter Gent from NCAR, and I'm basically an ocean modeler.
Give your current title.
But currently, I'm the chair of the Science Steering Committee for the CCSM.
I'm Michio Kawamiya. I forgot the name plate. I'm from JAMSTEC, Japan Agency for Marine Earth Science and Technology, and I'm a project manager in JAMSTEC to develop an Earth system model.
I'm Dave Ryan from GIS. I do climate and stratospheric.
I'm Dave Bader from Lawrence Livermore. I run ECMDI, which does most of the infrastructure for coordinated modeling experiments for WGCM.
I'm Peter Cox. I'm from the UK Centre for Ecology and Hydrology, formerly the Hadley Centre, and I'm interested in interactions between biosphere and climate change.
I'm Linda Mearns from NCAR, and I'm interested in too many things, which is why I can't stay this entire week. But I've worked a lot in climate scenario development, impacts of climate change on various sectors of human society.
David Kickler from the Marine Biological Laboratory. I've been involved in developing the terrestrial ecosystem model, and I've been working with the joint program in science and environmental change up at MIT and trying to see if we can make use of what the atmospheric chemists are saying and what the climate people are saying actually with the oceanographers.
Kathy Hibbert, I'm with NCAR, currently working for the IGBP Earth Systems Modeling Project.
Masaki Moto from CCSR, University of Tokyo, and I'm in charge of developing a climate model called Mirror in AR. We are in collaboration with Michio Kawamiya's group in developing the system.
Nebojša Nakicenovic, or Naki. I work on energy and technology modeling and emission scenarios. Half of the time I'm professor of energy economics at Vienna University of Technology, and the other half of the time I coordinate energy and technology programs at the ASA.
I'm Steve Smith, and I'm with the Joint Global Change Research Institute in College Park, and we do integrate actually what Naki said, and in the context of this group, we're both groups that produce emission scenarios that go into the GCMs, so we're interested both in improving the components of our modeling and also trying to make those more consistent with what's going on in the Earth system models.
I'm Jean-François Lamarck from NCAR, and I work on modeling of chemistry and climate interactions.
I'm Richard Moss. I work on human-environment interactions. I seem to have had an affiliation with a wide range of institutions over the last few years, including IGBP, IPCC, and the Climate Change Science Program.
I'm now with something called the UN Foundation, most of my time and part-time at the University of Maryland, ESIC.
George Hurt from the Institute for the Study of Earth, Oceans, and Space. That's everything. The University of New Hampshire. I'm basically an ecologist, but I work right at the intersection of terrestrial ecosystem ecology and climate modeling.
Michelle?
I'm Michelle Masoni. I'm a program assistant at WGCM.
I'm Sue Bookout, and I'm the Director of Operations at AOGCMs.
And I'm Michael Monroe, and I've had the opportunity to document most of these meetings, so I'm glad to be here again. Thank you.
And I'm Jerry Meehl from NCAR, and I'm co-chair of WGCM, and along with Kathy and Dave Schimmel and Colin, put this session together. So I guess maybe I should cue up the. I think it's kind of interesting that one of the areas of interest that people always want to know about from climate model projections are what's going to happen to extreme events. And you've had the opportunity to personally experience several extremes, mainly in the last 24 hours, possibly. The Denver heat wave was in the third heat wave of the summer in Denver yesterday. So those of you who came through Denver experienced the heat wave, and then yesterday evening experienced an intense precipitation event. And that's part of a climatological feature that affects the western part of North America called the North American monsoon circulation, which sets up in July pretty much every year. You get the elevated topography of the western part of the U.S. heating up. The air rises, draws in moist air from the south, and fuels thunderstorms like we had last night, and probably like we'll see the rest of the week. So this is kind of a full-on sense-around climate experience that we're having here. But what we're really trying to get at here are what's going to happen with Earth system models, or Earth system type models, over the next couple of years, actually. And so I think there's a number of kind of background bits of information that, since a number of you are coming from different areas, you start hearing these acronyms, you may wonder what the heck these acronyms all mean. This is kind of a list of some acronyms, and this isn't a complete list, but this is probably a list that covers a lot of the different acronyms that are involved. So WCRP is the first one. That's World Climate Research Program, and under WCRP there are at least two relevant groups. The first one is WGCM, which is the Working Group on Coupled Models. That's the one I'm involved with, as well as Masakamoto and Ron, and Dave Bader shows up to WGCM meetings. And WGCM basically has representatives from a lot of the different global coupled climate modeling groups from around the world. And WGCM is also the group that kind of took ownership over the coordinated experiments that were run for the IPCC AR4. Because we represent the climate modeling community in theory, it was felt that we should be the ones that at least tried to coordinate these experiments and kind of signed off on what scenarios we ended up running, and oversaw the collection of the model data. And Dave's shop there at PCMDI ended up archiving all this model data, and it's become a resource that close to 600 scientists have already signed up to look at, and it's been quite a successful operation in terms of getting a lot of people to look at these model outputs. SPARC is another WCRP group, Stratospheric Processes and Their Role in Climate, and Norm is, I guess, a co-chair of that. It involves...
I'm the project office director.
Okay, project office director.
Co-chairs are Ravi Shankar, and Alan O'Neill.
Okay.
Neither of whom are here.
Okay. And that basically you have atmospheric chemists and stratospheric dynamicists, and try to look and see how the stratosphere interacts with the rest of the climate system, and that's a fairly active group as well. So under IGBP, which is kind of the biogeochemistry area, the International Geosphere Biosphere Project. Thanks. Program. AIMES is the Analysis, Integration, and Modeling of the Earth System, and that's a reformation of the previous group that was GAME. Not quite sure what GAME stood for. Okay, yeah. So anyway, AIMES is the current acronym, and the project, as Kathy mentioned, the project office is at NCAR, and the co-chairs are Dave Schimmel and Colin Prentice, and they kind of represent the biogeochemistry community. And there's been a kind of a connection made between WGCM and AIMES over the past few years, and we've had 2 joint meetings to try to establish lines of communication as we kind of approach this Earth system modeling activity. And we're going to have another joint meeting in September, and I'll say a little bit more about how this workshop will feed into that in a minute. And then there's the IGAC, National Global Atmospheric Chemistry Program, you heard a little bit about already, which is under IGBP looking at, obviously, atmospheric chemistry. So those are probably, and there's more I think that we could think of, but those are probably the main ones that come to bear, at least for this particular workshop. And then on the IPCC side, there's at least 2 that you can think of. One is TGNES, the IPCC Task Group on New Emission Scenarios, and I think does that have a new name now? Is it reformed into something?
It doesn't really exist anymore.
Okay.
It still existed in Mauritius meeting.
But
Prepared the report for the Mauritius plenary.
But is there a succeeding group?
I think there might be 2. Well, I'll talk about
Okay,
it tomorrow.
okay, yeah.
It's as usual with the IPCC.
Yeah,
Unclear.
unclear, right.
But does it still have an acronym? That's
It's there.
So anyway, they put together a report on obviously on new emission scenarios, especially addressing this kind of new generation of scenarios, mitigation adaptation scenarios, which we're going to be talking about during this meeting. And TGICA, sorry.
That's important.
The task group on data and scenario support for impact and climate analysis that Linda is on. And Richard, yeah, actually, are you the chair still?
Richard's our fearless leader.
Okay, yeah.
I'm the co-chair.
You're the co-chair, okay. And it used to be TGCIA, and now it's TGICA.
Yes.
Yes.
Don't want to know why.
But anyway, they're the group that is kind of at the interface between the modeling community and the impacts community. And they oversee the IPCC Data Distribution Center in Hamburg, where model output, which is, I guess, kind of a subset of what Dave has at PCMDI, is kind of packaged and made more user-friendly for the impacts community. So anyway, there's all these groups that are kind of swirling around, and as we kind of come to a point where we're all going to have to try to bring to bear all of our expertise and knowledge in Earth system modeling, we need to try to enhance communication between all these groups. Because it's become apparent to the community now that we're really on the threshold of kind of a new era in climate modeling. And this, you can call it Earth system type components or Earth system models, or there's a number of different ways of thinking about it, of what they may end up being. But you can imagine now that we're at the point where a number of new components are ready to be added to so-called standard AOGCMs. And the AOGCMs, or global coupled climate models, or whatever you want to call them, have standard components of atmosphere, ocean, land, and sea ice. And these models now number around, what, 23, Dave? Something like 23 AOGCMs now internationally from 17 or so groups. And these
it's 17 is a number of groups.
Yeah, right. So anyway, there's a number of these models around now, and these are the models that were run using the scenarios for the AR4, using the 3 SRES scenarios, B1, A1B, and A2. These were viewed as kind of a low, medium, and high forcing, and then we ran out some other stabilization, really idealized stabilization experiments with these models as well. And now this is this model data archive that's being analyzed by a lot of people around the world. So this is what you may say, okay, that's kind of now a standard coupled model, or a standard model used for climate change projections. But now we're looking at candidate new components that include, and you could probably add a couple more to this, but there's at least these 4: carbon cycle, aerosols, chemistry, and dynamical vegetation. And these have been run in various forms in different types of models and kind of a parallel track to the AOGCMs. But we're seeing now that we're probably going to have an intersection of at least some of these components that will go into the AOGCMs. And so how that happens, when it happens, and why it may happen is kind of why we're here today to address these kinds of issues this week. And of course, the big issue is that for those of us that work with these AOGCMs, we already know that they have a lot of problems. There's a lot of things that we can't get right. There's a lot of systematic errors that are fairly persistent that we haven't been able to get out of them. But they're to the point now where they're pretty useful at looking at a lot of different aspects of climate variability and climate change, even when you do have those errors and problems associated with them. So we still worry a lot about what's in these models, but now you start talking about adding some of these components, and now you introduce new feedbacks into these models, and there's the question of how you constrain or understand those feedbacks and whether there's adequate observations to really diagnose if the model blows up or does something really strange. Is there a way to figure out how the feedbacks are occurring that you can make sense out of it? And so you can imagine a number of different aerosol, cloud, climate feedbacks, vegetation, ocean, biogeochemistry, climate feedbacks. There's a lot of kind of scientific issues involved when you start coupling in these new components. So what's happening this year and what's kind of prompted this workshop is that the modeling groups are counting back from the year 2013. And 2013 is the year that we think would be, if there is an IPCC Era 5, that's probably when it would be published. So okay, if you start thinking 2013 and you start counting back to where you have to really start developing and finalizing your model that you're going to be using for doing simulations that would be assessed in time for the publication, you're talking about having pretty much a functioning model in 2009. At least that's what we've guessed for the CCSM, and other groups I think are guessing the same kind of time frame. So that means this year, right now, modeling groups are making decisions about what's going to go into their next version of model that's going to be used for climate change projections.
Jerry, quick question. Assuming the IPCC AR5 publication date is early 2013, are you saying that this has already been determined?
No, we're just guessing that.
Because that's a lot longer than the time between.
Well, it's 6 years, so 2007.
6 years.
2001 to 2007 was 6 years, and so 2007
I guess that's true. All right.
I mean, this is, we're just assuming that this is going to actually continue to occur. Yeah, persistence is a good forecast, as Ron said. So what's happening now are, for example, at our CCSM workshop that was held last month in Breckenridge, there was already talk about, okay, what we think is going to go into our next version of the model, which would be the CCSM 4. When things have to be ready, when you have to start doing control runs, all these things are now being discussed, like now. And the other thing that's happening is that the TGNES and other groups are discussing new emission scenarios, and there's been a lot of work on new emission scenarios in Working Group 3 of the IPCC. We tried to make a connection between Working Group 1 and Working Group 3 in the AR4 to try to transfer some of these new mitigation scenarios so that we could actually run them with AOGCMs for the AR4. And it was really an intense kind of negotiation that went on, and we just kind of ran out of time on the Working Group 1 side. We'd have liked to have done more with the new scenarios, but it was just too new, and everything seemed to be not quite to the point where we could really have the time to do simulations and understand them with the new scenarios. So, but there are these new scenarios, and these are kind of being discussed and analyzed in Working Group 3 this year as well. So a number of people have recognized that there's kind of a confluence or convergence or whatever you want to call it of activities in this model development side and the scenario development side that we really have to come to grips with starting this year, because to get this kind of all straightened out and organized and coordinated, it's really kind of, we have to do something this year to address these things. So that's kind of the motivation of this workshop. Yeah.
Probably we'll go into this during the meeting, but are you completely sure there actually are going to be new scenarios? I've heard some conflicting evidence about them.
Well, that's why we got the scenario people here to tell us about that. So.
Yeah, there's some, I think, they need to be
So you probably have read these objectives of the workshop already. They were sent out with the invitation letter, but we kind of have 4 general objectives. And the idea is we're going to look at these 4 candidate new components and really see where we are now with these new components. And we're going to talk about near-term kinds of things. You know, which one of these or which group of these are ready to go in the AOGCMs now or within the next 6 months to a year, or when would they be ready to go in a standard kind of a way? So that's kind of one objective, to kind of address that question. We want to establish this communication among these different groups that we have representatives here to actually start talking about coordinating activities to prepare for these climate change simulations that groups anticipate they'll be doing for the next IPCC. And as part of that, we need to talk about kind of why we're going to be doing these experiments. You know, what's the experimental design? What kind of science questions do we want to get at to try to address interesting science to do with climate change? So that's going to be part of this workshop as well. And then if we think that certain Earth system models are going to go into these AOGCMs, what would be the requirements for the time series of various constituents that would be part of these scenarios? And who's going to produce those? So it's a matter of not only what is going to go in, but who's going to do this, or what groups, or how we decide on this kind of thing. So those are kind of the 4 main objectives of the workshop. So the strategy that we came up with was we thought we could have some initial overview talks on the current status and really near-term state of these different parts of this Earth system modeling equation. So really what's going on with AOGCMs right now, carbon cycle, dynamic veg, aerosols, chemistry, and scenarios. So we have a few people who have asked to give these kind of overview presentations and really talk about where we are right now and where we think this is going to go in the next year or so, or 6 months to a year. And then to kind of fill in the gaps, we're going to have breakout groups on these 4 component areas. And keeping in mind the 4 goals of the workshop, these breakout groups would kind of try to address those 4 goals and try to give us more information on that part of this Earth system modeling kind of activity. And then the other kind of part of this is experimental design for climate change experiments. So we're going to have 2 breakout groups. One to address an experimental design for interesting science questions we could address looking kind of mid-21st century, and then kind of longer term, end of the 21st century and beyond. And this would take into account what kind of models would be appropriate to use for those types of experiments on those time frames, and the scenarios and the requirements from scenarios that would be involved with this. Now, some groups are thinking that there may not just be one big Earth system model. We may still have different types of models. There may still be AOGCMs that are maybe higher resolution, and then Earth system type models that are a little bit lower resolution. But that's part of it, and that's part of this resource requirement, because that's a big issue with these emerging Earth system models. If you start adding all these interactive components in, the computer requirements go way up. And we're always struggling with computer requirements anyway, so that's another part of this as well. But how you decide which tool is most appropriate for which scientific question, I think, is a big part of this kind of experimental design part of this workshop. So the product, and John mentioned products, the product that we'd like to have come out of this is some kind of a white paper addressing these goals, and then and really giving a sense of what we as a group think is really happening and what should happen and what could happen over the next 1 to 2 years. And that's going to be used as input into the next joint meeting with WGCM and AIMES, which is going to be in September of this year. And at that meeting, we'll have more people there from more modeling groups, and they will be able to look at what we produced as a strategy and really discuss implementation and see which groups are really going to do, or what groups really think they're going to do over the next few years. So basically what we're talking about is a strategy in terms of not only modeling tools, but scenarios and experiments and experimental designs for coordinated experiments for the IPCC Era 5. So that's kind of where this is all headed, with the idea being that we're starting now when groups are still in the formative stages of trying to decide what it is they're going to do. So we get people communicating with each other now, so we don't get into a situation where everybody goes off in different directions, and then it's hard to pull it all back together, 3 years from now when we decide we needed to start doing some experiments. So that's kind of the general goals of the workshop. Any questions, Ron?
What exactly are the 4 breakout groups?
So they're
Next slide.
it'd just be these: carbon cycle, aerosols, chemistry, and dynamical vegetation. So those are the first 4, and then the later in the meeting we'll have 2 groups. So the idea is that we try to, and so people would probably go into these breakout groups based on their immediate interests, on what they think they're most interested in terms of those 4 different components. And then you'd have more of an integrative look at these things for these experimental design working groups. So in experimental design, you say, okay, if carbon cycle we think is ready to go into standard models now, or if dynamic vegetation or whatever, if we think that's really going to go into an Earth system type model, how would you design an experiment to address certain scientific questions with that type of model for near term and longer term, so mid 21st century and late 21st century? And that would kind of synthesize what kind of scenarios you'd use, what's in the scenarios, for what, say, space scales would be involved as well. And so that's these experimental design working groups would be more integrative across these different parts of the Earth system modeling activities.
I think what you have been framing there is exactly what we need, and it's good to do it as early as possible. However, there is a bit of an issue which I think could take 3 days of discussion. But what is the definition of an Earth system model? We don't want to go into that. But I'm raising this because there is a lot of discussion on that and papers on that, and the way we approach it here is of course a very specific way of approaching it. It isn't, we're talking about Earth system model, but in fact we're talking about expanded climate model to other aspects. It's still a very climate-centric type of Earth system model, which is what we need for IPCC, so I'm not questioning this. But of course there are other people, and I know in IGBP, for example, that came up very often, that look at Earth system model in a more, I would say, balanced way, where climate is one part of it, but there are other aspects which are also important. The state of the biosphere, the state of the air quality, and they're depending on climate. So climate is sometimes even seen in these models as a forcing to other aspects, and these are called Earth system model. Now there are also people who claim that an Earth system model is a model that has a human dimension, or social, that the social system is part of it, otherwise it's not an Earth system model, which is not what we are doing here. But I think we should remember the more general framework in which we evolve, because there are aspects that might come up more and more in IPCC also. First of all is the connection between the physical system and the social system, which, in a broad term, needs to be addressed somehow, maybe not for this, and not here at this meeting necessarily, but in the future. And then the regional aspects, which are becoming more and more important, where the interaction, the Earth system interaction might be more easily captured in models than on the global scale. So I just wanted to make this point because as we start using, without thinking too much about it, the words Earth system model, we should remember that we are looking here at a very specific Earth system model, and that other communities, which are partly represented here, might not feel that this is really an Earth system model. Right. This is a certain type of Earth system model.
Yeah, so we tried to use the disclaimer Earth system type model, which dodges the. Yeah, right. Dave?
Yeah, and as a follow-up to that, and this would fall under the category still of an Earth system type model. When discussing what should be in these, we should keep in mind that the IPCC Working Group 2 wants output from these models for their impact assessment, so that we should try to understand that what we're going to include in these models is not only for Working Group 1 purpose, but Working Group 2 and CIC3 as well.
Yeah. So that was the idea of getting Linda and Richard here, because they're at that interface in Tajika. Tajika, sorry. Elvin?
Yeah, of course I agree with what Guy said and David, but I think these kinds of efforts, I mean, there's a great deal of coupling to get done, and I think we can discuss this a little bit here, but how to just go about that, especially incorporating human dimensions, is really extraordinarily complex. It's not like just coupling in a little more better chemistry. And as a matter of fact, one of the things I want to discuss with the AGCI people is the possibility of putting on a separate workshop maybe next summer on human dimensions and Earth systems models. But I think right now it's really too complex to try to put it all together, and the human dimensions community ends up being still important, but more still the tail as opposed to the dog.
Yeah, of course the human behavior is kind of implicit in some of the scenarios, especially these mitigation adaptation scenarios. So that's part of it also. Richard?
Yeah, well, on the mitigation scenario side, I think that I'm kind of startled in a way, stepping out and running the science program for the last 6 years, and now engaging much more with people who are worried about solutions to the climate issue. At a policy level, people are really gravitating very, very rapidly towards large ramp up of various renewable energy technologies, particularly biomass, but also others. And one of the things I wonder about whether there's a big disconnect that I think is a really first order problem is on the issues of the physical requirements, the climate and other requirements for these biomass scenarios, and what people are projecting that they can do on the energy side. So that, to me, that's a really important issue, and it does, I think, extend the client base beyond thinking just about Working Group 2 and impacts to really integrating much more actively than we have in the past the Working Group 3 and mitigation community.
Yeah, I just wanted to add to that. I mean, we have spent at YASA last 4 years working exactly on this issue that Richard was raising. The intersection between mitigation measures, in particular those that are related to the land use and other land use purposes. So I think that's one area where integration is already occurring, and we have to think how to do the next generation of modeling. Another thing I wanted to mention is that over the last few years, the community has shifted to doing multi-gas mitigation and stabilization scenario. So in the old days, when the focus was only on CO2 or CO2 only in mitigation cases, it was sufficient just to look at the emissions. But now that we are dealing with multi-gas, we have to go all the way into the climate system and look at radiative forcing and delta T. So that integration and coordination of the efforts, I think, is now quite upfront on the priorities.
Well, but I think that's sort of well underway, even at the level when we did SRAS. I mean, the climate modelers, all incorporated the full suite of gases. I mean, the only big lack was the reactive gases were probably not realistic in many of the scenarios, and that's been corrected since then. So, and then with, I think Richard's, this issue of the land requirements is important, although it's not
just land though.
Well, I know all that, but it's not the primary issue of this group. I mean, there's groups that, like Naki's, that have been looking at this for quite some time and have, and actually there's a 2 days meeting down the road at Snowmass this week, which is why I'll have to duck out partially, Wednesday and Thursday, looking at exactly that issue. So that is the issue that the community is looking at. So I think the issue for this group is then how do these, however you define it, their system models as represented in this room, do simulations that are consistent with that, and in terms of land use. It's not, I wouldn't advise, a completely separate effort to try to figure out the land and water and other implications of all this, but there needs to be interaction and work between the two groups to make those consistent. And I don't think you were implying that, but just to make that clear.
Yeah, I think that's kind of the idea of trying to have, this is an initial step in that direction to try to at least make people aware of what's going on in these other communities. And if we start saying, well, okay, we want to do a certain type of experiment suite, how can we make the best use of those experiments based on all these other considerations? I think that's kind of what we really want to try to achieve.
Yeah, I mean, my point wasn't to deflect what you're trying to do here, but just to give a sense that if you're talking about an assessment that's going to be in 2013 and you're worrying about what the users are going to need, 2013 they're really going to be well down the road towards trying to look at these mitigation scenarios.
Right.
And something that addresses that issue will really be important and helpful. That's all I was trying to say.
Okay, Kathy, did you have anything else you wanted to add from an meeting organizer point of view?
Later on in the week, when some people will be ducking out, unfortunately, we were going to try and address some of those concerns through the appropriate near-term and long-term experimental designs that the various models might be able to work at efficiently and effectively. So a near-term experiment could be higher resolution, much more information, shorter time frame. In the longer term, a lower resolution type model, looking at different kinds of questions. And so that's, we tried to structure this so that we were addressing these attributes that are being included in the models: vegetation, carbon cycle aerosols, full climate chemistry, and then weave that into what kind of experimental design can we develop that takes advantage of things that require much different kinds of information for the next scenario. So I think that's...
What would be short term?
What do we talk about?
Mid
like
21st century.
10, 20 years, yeah. And long term being the traditional 2100.
I was wondering about these two timescales. What are the reasons behind them? 2040, 2050, I can understand, because that's probably where the signal from climate change will be stronger than natural variability in every region of the world. And also, the emission scenario doesn't matter too much. The divergence will come after that. The 2100, I think it's basically inertia from the previous IPCC assessment. Shouldn't we look beyond that, especially in terms of the mitigation scenarios?
So I think we use the word 2100 and beyond. So, I mean, this is the thing with these SRES scenarios that we're trying to make the point in the R4 now, is that if you're looking on the near term, 30 years out, the scenario doesn't make that much difference. The model doesn't make that much difference, because you see the big spread when you get out later in the century. So if you're talking about near term, you may actually be looking at a little bit different mentality in terms of what you're talking about. When you get further out, then you're looking really at these longer term kinds of prospects.
But you actually have an advantage when you look at mitigation scenarios, because the long-term mitigation scenarios are actually much better defined after 2100 than the non-mitigation scenarios become increasingly, ridiculous, after you go after, because if climate sensitivity is above, 1, there's not going to be there's going to be mitigation of some sort.
Yeah.
But the mitigation scenarios, if you stabilize forcing or getting close to it by 2100, that's much easier to project out. But which is good. I mean, but and then we can really look at the differences in these models in terms of inertia and so on, and what commitments and what components of, if you change, aerosols are small by that time, you're more in a pure greenhouse gas signal. So it's actually a much more tractable problem.
Last question.
At least with not a question, but a comment. At least with my work with the MIT group, is the economists don't want to look past 30 years.
Yeah.
They just think too many things have changed that it's just not worth looking
Well,
at.
some of the economists look quite that's it.
But there's a...
Not all economists are.
And also, in talking to people like demographers and things that are that community, they have a lot of faith in their estimates of how human populations are going to respond in 10, 20, maybe 30 years. But when you start going 50 to 100 years, it's just it's not reliable. So just sort of.
But that's why we.
But that's why we do it. Yeah, there's a purpose for both time frames.
Okay, so.